Okay, so here I have cleaned up this last formula that we have achieved. Now let me show you how we can proceed, how we can carry out this integration to obtain the normalization that we need for the Blin microfacet distribution. Okay, so this is a bit confusing for the following reason. We have both alpha and WH, but they are actually related to each other. So this integration, when we carry out this integration, we are carrying out as a function of alpha, but WH is also changing when alpha changes, right? So this is the surface normal. We call this angle WH, and this is alpha. Okay, so if we go first of all one step here, we have we are integrating cos alpha pi plus 1 or p plus 1, okay, dWh should be 1, and then we continue one more step, so we expand this, so we are going to integrate from 0 to 2 pi, right? So all basically WHs around the normal, and also we are going to integrate from 0 to pi over 2. Okay, so remember this is basically, we are going to replace this is the solid angle with our solid angle formula. So how do we do this? We have cos alpha pi plus 1 and then sin alpha. So WH, dWH is going to be, what is it? It's going to be d alpha and then d phi. Okay, so please don't get confused. Previously we were writing theta here, but here we are doing integration with respect to alpha. So we call this angle alpha. Okay, so therefore the solid angle became sin alpha, d phi. And phi is our, again, angle around the surface normal. Okay, so how can we get an integration? How can we integrate this? We need to do substitution. Okay, so you can try different things to substitute, but I know what it should be substituted with. So we just say here u is equal to cosine alpha pi plus 2 to the power pi p plus 2. Okay, sorry, I get confused. Now if we then compute if we compute then du d alpha, we are going to get so the derivative of this, so this is like a chain rule, right? So the derivative of this is going to be minus sin alpha, and then the derivative of the other function, which is going to be p plus 2, and then we have cosine alpha p plus 1. Okay, so from here, if you compute what is du is actually minus sin alpha p plus 2 cosine alpha to the power p plus 1 d alpha. Okay, so here you can see that we have almost produced the same thing here. So here we have sine cosine to the power pi plus 1 and d alpha. So sine cosine d alpha. Okay, so what we can do is here we can replace this part as follows, right? We can write here, I can remove these things and write instead of them minus du divided by p plus 2. Okay, so from this relationship I could replace it with that, but we said u is equal to cos alpha to the power p plus 2. So if you put 0 for cos 0 is 1, so we are going to have 1 here, and cos pi over 2 is going to be 0. Okay, now let's also get rid of this integral here. So you can see this is just an integral of d over d phi from 0 to 2 pi. So actually, this I can clean this up, and this is going to be 2 pi. Okay, and let's do one more cleaning. So pi plus 2 is constant. Okay, so pi plus 2 we are going to have, it goes to here. Okay, now if we carry out this integration, this is going to give us, so we will do these boundaries, and it's actually going to give us 2 pi divided by pi plus 2. Okay, so this is the result of the integration, but this was supposed to be equal to 1, right? But it didn't end up being 1. It ended up being 2 pi divided by p plus 2. So actually we should be normalizing them. We should be normalizing this BRDF, this distribution function, I'm sorry, with a constant. Let's call it c. And this c should be actually p plus 2 divided by 2 pi. Because if we had a constant like that here, when it gets multiplied, we are going to obtain 1 as a result. So to summarize, the normalized Blin microfacet distribution is equal to p plus 2 divided by 2 pi, and then cosinus alpha to the power of pi.